Your heat pump can change the temperature of the water going through your radiators without you constantly changing the thermostat. And it does this partly because of the temperature outside your house. When the weather gets colder, your home loses heat faster, but loses less heat when the weather gets milder. So a heat pump shouldn't necessarily send the same degree of hot water through the system on a 12 degrees Celsius autumn day as it does when it's -3 degrees Celsius in January. The system that helps it make that adjustment is the weather compensation. How does your heat pump decide how warm the water needs to be? The setup. So let's say you want your living room at 20 degrees Celsius and it's 15 degrees Celsius outside. There's only a 5-degree difference between indoors and outdoors. But imagine it's -5 degrees Celsius outside. That's a 25-degree difference, leading your house to lose heat much faster. And to maintain the indoor temperature to remain at 20 degrees Celsius, the heat pump has to replace that lost heat through weather compensation. When the weather is mild or cold outside, the required flow temperature is adjusted by the heating system. And the relationship between those two temperatures is the heating curve. The finding. Before a properly designed heat pump is installed, your home should have a room-by-room heat loss calculation. The calculation estimates how much heat the building will lose under specified winter conditions. For example, a property with a calculated heat requirement of about 7.34 kilowatts when the outdoor temperature drops to -5 degrees Celsius. The property's heating system could be designed for around 45 degrees Celsius flow temperature at those conditions. To maintain the desired indoor temperature, the heating system needs to replace roughly that heat loss from the cold weather. Your radiators or underfloor heating also need to deliver sufficient output, and their output depends partly on the temperature of the water passing through them. What does the heating curve do? The colder outside is, the higher required flow temperature, and the warmer outside is, the lower required flow temperature. If it's 14 degrees Celsius outside, but the system is still producing 40 to 55 degrees Celsius water as though it's a freezing January morning, then we can't say the system is operating efficiently. The impact. Heat pumps generally perform better when they can meet the building's heating demand using a lower flow temperature. The reason is the heat pump is taking low-temperature heat from outside and raising it to a useful temperature for the heating system. The greater the temperature difference it must overcome, the harder the refrigeration cycle generally must work. This repeated process of adjusting the flow temperature in correlation to the outdoors temperature is known as cycling. Also reducing flow temperature as outdoor temperatures rise helps the heat pump better match the building's falling heat demand and can reduce cycling. So weather compensation is trying to avoid two extremes. Too much heat when the house doesn't need it, and not enough heat when the house does. The real objective of heat pump efficiency: use the lowest practical flow temperature that can still replace the heat a home is losing and keep it comfortable. Should you change the curve yourself? Your installer should establish the initial weather compensation settings when the system is designed and commissioned. The starting point should relate to your home's heat loss, emitters, and design conditions. Many heat pumps provide simpler ways of fine-tuning weather compensation. Some systems allow an offset, which can shift the curve warmer or cooler without completely redesigning it. Before changing anything, find out what the manufacturer's guide says. In the next video, we're going to discuss heat pump myths that cost homeowners money. If you're following these Heat Pump Basics series, please subscribe to the channel. Thanks for watching, and I'll see you in the next video.